In this video, we'll take a look at configuring a very basic IP SLA. This particular example will not use an IP SLA responder, so we'll be creating a very basic configuration that's going to use the ICMP echo function to check for the reachability of a device on our network. Exploring all of the configurations of IP SLA would encompass its very own video series because they are numerous, but in this example and the subsequent videos, we're going to cover the Cisco blueprint requirements of making sure you know how to configure IP SLA and that you know where you can find those additional configuration options. You can see from on screen that we have a really basic topology here. We have a couple of interconnected routers, and we have a server. You can see that the server is sitting at 10.0.0.6 in this example, and we're going to create a very simple IP SLA that will check on the connectivity status of this server so that we can be alerted if the server becomes unreachable. You can verify whether or not your particular device supports a specific IP SLA configuration with the command show IP SLA application. And under here, we're going to see a list of all of the available IP SLA operations. Not all of these operations are supported on every single device, so that is something to be aware of. We can see here that we have several supported options, which are fairly numerous. We see ICMP echo, we see jitter, we see voice over IP, just to name a few of those. So lots and lots of options. We're here on router 1. Let's start under global configuration mode, and let's start with the command IP SLA. And if we look at contextual help, we can follow that with an entry number. So each IP SLA probe that we configure will have its own individual entry number to identify it. In this case, let's just use number 1. And if we hit enter, we're now under IP SLA configuration mode on this router. If we take a look at our contextual help options, you can see all of the available operations that we're able to configure. In our case, since we're testing basic reachability to our server, we want to use the keyword ICMP-echo. And we need to follow that with the IP address or host name for the destination that we want to monitor. In our case, that's the server at 10.0.0.6. If we look at contextual help again, we'll see that we have two optional keywords here. We can specify the source IP address. So in other words, if we want to mark these ICMP packets from a specific source, we can do that, or we can specify a source interface as well. We won't bother with either of those options in this case. We'll just hit enter. Now notice we're under IP SLA ICMP echo configuration mode. So here we're setting options for our ICMP echo function. If we look at contextual help, you can see that we again have quite a few options here. I'm going to choose the frequency option in this particular example, and I want to set the frequency for this IP SLA probe. Help indicates that this will be set in seconds, so maybe we want this to probe every 3 minutes. In my case, we can do that by putting in 180 for 180 seconds. We can see some results in our output later. Since this is a lab environment and I want to set that really low, I'm actually going to set that to 10 seconds. We wouldn't want to do that in production most likely, but here in this lab, it's okay to do that. So I'll set that to 10. We can run any additional sub-commands here that you want to. If we wanted to set things like threshold or timeouts, we could run those under this ICMP echo configuration mode as well. In my case, I'm going to keep it pretty simple. I'm going to leave it basic, and I'm going to leave it right there. I'm going to hit enter. I'm going to go back to global configuration mode now. Now that we have our IP SLA configured, we need to actually start the probe. If we say IP SLA and we look at our contextual help again, near the bottom, we see the schedule keyword. That allows us to schedule the entry, schedule a start time for that. It's going to allow us to schedule parameters for each of our IP SLA operations. We can say schedule, and we need to follow that with the entry number that we're scheduling, which is of course 1, and help indicates more options for this probe, such as when it should start and how long it should operate. So to start with, let's say start-time, and again under those options, we can see a few things. We can set this to start after a certain amount of time. So say if we wanted to do that 5 minutes from now, we could do that. Or we could set a very specific start time, even down to the number of seconds. We can make that pending so that it's activated, but no information is collected yet. We can set it to random, or we can set it to now. In my case, I want to set that to now. I want it to start right away. And if we look at contextual help again, we can see the recurring option. So that's going to run this operation every day. We can also age out the operation from memory after a certain interval if we want to do that, or we can set a lifetime value. I'm going to set a lifetime value, so I'll say life. And if I look at contextual help, you can see that by default, that sets to 3,600 seconds. Since I want this to run indefinitely, in this example, I'm going to say forever in our case, and I'm going to hit enter, and you can see right away what happens if we do that. We get an error, and that's because when we're in recurring mode, it's redundant to set a lifetime of more than 1 day. So basically, this is telling you that these commands are redundant and that one of those is unnecessary. So I'm going to arrow up, and I'm going to remove that recurring keyword, and I'm going to hit enter to accept that. If we back out of here and we say show IP SLA configuration 1, which is the one that we just configured, you can see that our configuration is displayed in this output. We can see that this is at the top an ICMP echo operation. We see that pointing over to the 10.0.0.6 destination. The source address is listed as all zeros, meaning that any valid IP address on this router would be set as a source. And we can see our next scheduled start time is set to already passed. So that's good. It's already up and going. And just above that, we can see our operation frequency that we set, which is every 10 seconds. So that's good. And that is also never going to age out. We can see that it's listed as a lifetime. Life seconds are listed as forever. If we run the command show IP SLA statistics, then we can see some information about this. We get a more basic output letting us know that we have IP SLA operation number 1 running. We see our last round trip time. We can see our number of successes. We can see our return code. Our last return code was okay, meaning that this hasn't crossed any thresholds that we've set. And we would, additionally, if we had any failures, we would see failures in here. We do see 8 successes, so we've had 8 successes in this very short interval. Let me jump over to router 2. Let's go under our interface gig 0/2 in this case. And let's say shut. We want to shut down that port so that now the interface where the server is connected has been shut down, and the server is going to be unreachable by our IP SLA probe. IP SLA would be sending out SNMP trap messages about these failures, and those would go out via syslog. Those would be handled by a syslog server, and an administrator would be alerted depending on how we've configured that. But we can also see this on the local router that we just looked at. If we go back to router 1 and we again run that same show command, if we say show IP SLA statistics, and this time notice that the last operation return code was a timeout, and we're up to 3 failures now. So we see that is populating in our IP SLA statistics. We see that there's not a lot of information here, but we can see that it's a failure. A really good syslog server is going to be much more helpful when we're alerting about these types of violations. We wouldn't want to depend on the output of this show command. We would want this to work together with some sort of SNMP alerting system. So that's a basic look at IP SLA configuration using the ICMP echo function to monitor the reachability of a network device.